Okay, 6.4. If I saw something like this, I have to figure out which of the following are equivalent to, this mess, 4 log u to the negative 1/3. If I saw that, what I would be thinking maybe is that this negative 1/3 power, I can be pulled out to the side and times in front of the log, as well as, since that is a 4 that's already timesing in front of the log, it could also be pulled in and be part of the power. And so we could interchange those things or put them both on the left-hand side in front, or we could put them both as the exponent inside, or, switch them back and forth, whatever. And so I'm thinking that that'll be important to remember, as well as other things to remember. If I have a fraction-y exponent like this negative 1/3, that's also known as, we have a radical way to write that. And so I wouldn't necessarily discount any of these radical things like this one. It might still work. Let's see. Okay, let's see if any of these things on the left-hand side end up actually being equivalent to that one. Let's see here. Maybe I could start playing around with, what if I took the exponent here outside? Then I could times the negative 1/3 out to the left, and that would be 4 times 1/3 negative, and then log of u. Then they'd both be out on the left, and then I just figure out what 4/3. 4 times negative 1/3 is negative 4/3 log u. And then I'll see if anything looks like that. Looks like indeed we have one over here that looks like that, so that one's correct. That'll work. Here, I'll put a check or something. I don't know. How do you do a check? Whatever. And then let's see if we could also maybe take the exponent and put them both inside, both the 4 and the 1/3 inside. I might try. And so we could be like log of u to the, and then times the 4 and the negative 1/3 inside there on the exponent part. Then we'd have u to the negative 4/3 power there after I times those. And let's see if that's on the left-hand side here. I'm seeing a u to the 4/3. Not seeing anything quite like that. Although I guess we could say, might be able to make this one work. See that with the negative out in front of the logarithm? If I had just times the 4, and then if I took a negative 1, because there's a factor of negative 1 that makes that negative, and I took the negative outside, or the negative 1 outside, then this could be a positive 4/3, and the log could be negative. That'll work. So this thing's working. Also, if I did leave that negative on the inside, if I didn't pull it out, but I left it on the inside here, and this were a negative 1/3 power still, then 4 times 1/3 negative, I just accidentally erased all that. Whoa. Now I just erased everything. Let's see if I can redo some of that. Did that help? Okay. 4/3 negative. Where was I? Oh, yeah. If that's going to be a positive power, then we could, or a negative power, we could also say that that's like, let's see here, that'd be u to the, u to the negative 4/3. That's like a downstairs of u to the 4/3. That's 4/3 downstairs, or 1 over 4/3. That'd be u to that. I guess the u is down there already. Anyway, hopefully that shows up. Let's see here. Log of 1 over u to the 4/3 is showing up. Yes, that's good. That one's over there. Okay. Let's see. We only have a couple other options. Yes. Okay. So then you see this radical one on the left-hand side, top left? That one I think we can make work from everything we already have, because this actually is equivalent to, see that 1 over u to the 4/3? If I have a 4/3 power of u, that's like me saying u to the 4th, and then 3 root it, or 3rd root it, cube root it, whatever you like, and that's this guy. I'm thinking that probably all of these are equivalent. Let's see if we can do anything to make that last option work. And I think that will too. Let's see. If I look at that, I have a negative 1/3 on the outside. Here, let's look at that real quick. Negative 1/3 on the outside, and then the 4 is in the exponent spot. I think that's what we get. Yeah, we'll just switch places with these things, with the 4 and the 1/3. Because, again, that negative 1/3 can come out, and then we'll have the log of u, and then the 4 can go into the exponent spot, And I think that's exactly what this one is. So that's all of them. Well, that was cool. Maybe that was the moral of the story. They just want you to know there's so many different ways to write stuff that they all match. Okay, those take a lot of time to figure out, but then, let's see, this will be a little bit easier. I just have to put this thing in exponential form. You guys probably know how to do that by now. Let's see, that'll be t to the q power equals u, and I think that's all they want to have. T to the q power equals u, just doing that this to that power equals the other. That's good. Then the next one they say solve, and this is just the same kind of thing, but with numbers. Probably we'll put it in exponential form. So we have a 4 down there. That'll be 4 to the 9 power equals a. Then we're just solving it, and you just say, I know what a is. It's whatever 4 to the 9th is, and shoot 4 to the 9 in a calculator, and you'll be good. If we had something like number 6 here, probably I'll try that in exponent form too. So that's a base 3, so that'll be 3 to the 7 power equals x to the 5. And from there, we'll get x by itself. And so to undo a 5th power, we could actually take a 5th root of both sides would be one way to go about this. And so then we'd say x is by itself, and it's just whatever the 5th root of 3 to the 7 is, and that's also calculator work. And then just remember they're asking you to round to 4 decimal places. Or else you can put it in as an exact value as well. So you could actually put in a 5th root of 3 to the 7 right into the answer box if you like. That would be an exact value. Or if you don't know how to put that in there, if you don't like to, you can shove this in a calculator and then round it out to 4 decimal places. Next deal, on number 7, this is a funny stacked logarithm thing, and so I figured you might want to see that. If we start with the very first logarithm here, very first logarithm is base 3. So that'll be 3, if I put this in exponent form, 3 to the minus 2 power, 3 to the minus 2, equals whatever is inside the logarithm. And that's a whole other logarithm, which is log base 3 of x. And then we're there, and then somehow it seems like it's at least getting a little better, but it's a little mysterious still. So because there's still an x inside of the logarithm. So maybe once we figure out what 3 to the negative 2 is, maybe we'll go ahead and just try and translate it into exponent form again, And so 3 to the negative 2 is 1 over 3 to the 2. I think that's 1/9. You could double check that. I think it's just regular 1/9 equals log base 3 of x. And then to translate that into exponent form, though, over here, we'll put that all in exponent form. We'll say that's a base number of 3 to the 1/9 power equals x. A little bit weird doing that backwards when I wrote the log backward, but it'll work. And then we have x by itself. X equals 3 to the 1/9 power, not 3 and 1/9, but 3 to the 1/9 power. So it's a little exponent 1/9, or in other words, it's the 9th root of 3. And once again, you might be able to get away with just doing 3 to the 1/9 power in the answer box, or else you can do that in a calculator, and then probably they want it out to 4 decimal places. They didn't really specify there. On number 8 here, log base 2 of all that mess, 5x plus 3 equals 2, and we got to solve it. So I would recommend if there are x's stuck inside of the logarithm, let's go ahead and put it in exponential form, see if it helps. So this is a base of 2, base 2 in the logarithm, so it'll be base number 2 for us as well, to the 2 power equals 5x plus 3, and that'll be good because that's something we could solve, no big deal. 2 to the 2 is 4, and then we have 5x plus 3 equals that 4. And then it's just as easy as solving the equation, If you got 5x plus 3, we'll minus the 3 and stuff, And then you got 5x. Whoa. Let's try it again. You got 5x equals 4 minus 3 is 1. And then divide the 5 and you're done. X is just 1/5 in my case, or whatever numbers you get. Something like that should work. Okay, a little bit more intense here when we have these different logarithm things here. 2 different logarithm expressions, 2 logs in the same equation. I might suggest it'd be easier to squash them into one logarithm. And just remember, when we squish them into one logarithm, that plus of the two becomes back into a times. So this would be a times of x timesing with x plus 1. X times x plus 1. That's all in the logarithm. Okay. It is a common log, right? Scribble, yeah, these are common logs. Equals 4. And now that I have it written as a single logarithm, maybe we'll try it in exponent form since it's going nowhere now. And also remember, this is a common log, so if there's no base number given, it's a 10 down there. So in exponent form, this is 10 to the, why would I put 11? Okay, this is 10 to the 4 power. 10 to the 4 equals x times x plus 1. And then we're just solving this. Now 10 to the 4 is a big number. That's 1, 2, 3, 4 zeros. You're looking at 10,000 here equals x squared plus x. Or you could just keep calling it 10 to the 4th if you like, if it's easier to write that. Because in a second here, we're going to get this zeroed out here. If I minus out the 10,000 from both sides, then we could say, well, this is 0 equals x squared plus essentially 1x or something minus 10,000. Stopped doing the cursive 10,000 thing. Anyway, from there, it's looking pretty good. This is not likely going to factor. Every once in a while, that might work. But since it probably ain't going to factor, it'll look like more like ABC, probably quadratic formula stuff. And so, I mean, just to give you a flavor of what it'll look like, you can probably do this in your calculator, the whole thing, if you have a decent calculator. Otherwise, feel free to go up by hand if you like. But we have x equals negative b, which is a minus of 1. And then we're going to go either plus or minus, and are actually going to keep only the plus on that one because of issues with the domain of logarithms, because we're essentially solving a log equation here. So if I come up with a negative answer, I'm not going to be able to plug a negative into my logarithm. And so for that reason, we're not going to bother with the minus version of, the result from the quadratic. And so then negative 1 plus or minus 1 squared is the b term. 1 squared minus 4 times a times c. Oops, running out of room there. And so then the a is also 1, and the c is like 10,000. I'm going to put 10k as though you can read it. All that stuff over 2a is 2 times 1. And again, work this stuff like you would on quadratic formula, or else just shove the whole thing into a calculator, and that would be fine. Be careful, of course. If you put it in a calculator, you probably need to put an extra set of parentheses around all of this fraction, the top of it, just to make sure that everything is taken care of well. Anyway, hit me up if you're having trouble entering things in a calculator, of course. A couple of similar issues here. On number 10, just notice that these two logarithms are minusing. And so when we shove them together, minus becomes back like a divide. So it would be like x plus 4 here. It would be a logarithm of x plus 4 divided by x plus 3 equals then 1 as a single logarithm. And these are common logs as well. So if I put this in exponent form, that's a log base 10. So we're looking at 10 to the 1, on the other side. So we'll say, okay, yes, we'll say 10 to the 1 equals x plus 4 times, or over x plus 3. And then it's looking like 10 to the 1, we just as well call it 10. And we'll probably solve it like the old-fashioned way from there, and just notice that I don't want to deal with fractions. I'll times this x plus 3 over to here. Times it over to there. If you did it on both sides, it's like it would cancel out here. And then we'll times 1 over on the left-hand side. So then we have x plus 3 timesing with 10, and we'll distribute that, equals x plus 4. And then it's just 10 distributed to the x plus 3. And then from there, it'll be like solving the old-fashioned stuff. 10x plus 30 equals x plus 4. And then solve away. I'm going to put the ellipsis there. Solve like crazy from there. Just notice a few things. You certainly wouldn't want to get a negative 3 for an answer, because if you did, then x plus 3 would make this thing undefined. That would be bad. So any other number would be good, though. Probably going to watch out for getting negative answers or anything that's small enough, if you plug it in to one of these original logarithms, would give you a negative answer or a negative input to the logarithm. That would be bad news. Other than that, just solve away and you'll be good. I think I just changed the pen here. Yeah, pen font, whatever. And so, let's see. On number 11, I'm trying to erase this mess. Erasing. Okay. On number 11, similar stuff. It's still 2 logarithms minusing. So I'll just go ahead and minus them, becomes divide. I'm looking at that log. Will end up looking like probably x squared. No, x to the 2. X squared over x plus 4. And then it's a log base 5. And it's a lot like the last one, but it's a log base 5. So when you change the exponent form, it'll be 5 to the 8 power. This one just gets a little bit uglier when you solve it. It's the reason I bring this one up. Because then it'll be 5 to the 8 equals x squared over x plus 4. And that's no problem right now. In a minute, we're going to have to get this thing, x by itself. So the way it would go from there is, once again, we'll times the x plus 4 for the other side. So we'll have 5 to the 8 distributing to that x plus 4 equals x squared. And then distributing it, 5 to the 8 to both of those, it'll be 5 to the 8, which is some huge old number. Notice how I keep refusing to figure out how much 5 to the 8th is. And then 5 to the 8th times 4, we'll just call that 5 to the 8. Whoa. 5 to the 8 times 4 with a little times dot equals x squared. And then we'll get this thing by itself. But probably what I would do is, once I get the x squared, or the x by itself, to get this thing equal to 0, once we get this thing zeroed out like we did on the last one, we'll just keep the x squared in its place and move these other things over to the left. We'll have x squared, then minus 5 to the 8 power x, and then minus 5 to the 8 times 4 for the constant. At that point, what you're looking at is you have an a and a b and a c. And 5 to the 8 is some big number. If you want to put that in a calculator as being whatever 5 to the 8th power is, it's a huge number. Several thousand. Go ahead. Otherwise, feel free to just plug it in as 5 to the 8th when you're doing your a and b and c. So a is 1, b is negative 5 to the 8th. Don't forget your negative. And then c is negative of 5 to the 8th times 4. And you can actually just shove the whole thing as being the c term, because the calculator will know that that's a number, Anyway, think about that. That would probably be the easier way. But if you don't like that, feel free to just times it out and figure out what 5 to the 8th is, Okay. Similar here but different. This one solves a little bit differently. We have log of x plus 3 is just what it is. That's log of x plus 3. But then on the right-hand side, if I squash those two logs together, we got log of, and then plus becomes like times again. So then that's an x timesing with a 3. But instead of x3, we'll probably call that 3x. And then once we're there, what's cool about this is these are both logarithms. So the log of this is equal to the log of that. Means that we don't really need to deal with the logs. That means that x plus 3 must be the same thing as 3x in the first place. And then you just solve it. Maybe minus this x over there, minus x. And then I'm getting 3 equals like 3 minus 2 would be like a 2x, and then you just solve it out. Looks like if you get something like my version of the problem, I'm getting 3 over 2, and that's all we would need. Finally here, guys, we have a weird looking one. It's not too big a deal, but just watch the details. I have a 9/4 timesing in front of the logarithm. Might be easier for me to go ahead and put that thing inside of the logarithm as a power of the x, like we do. Not because you would have to, but because I feel like it might translate things a little bit more smoothly that way. So let's see. If we said, this is another way of writing that would be log base 3 of x to the 9/4 power. Pretend you can read that. 9/4 power equals 10. And then it's like it's all ready to just go, to be put in exponential form. So we could be like 3 to the 10 equals x to the 9/4. And that's weird. And then we just got to get x by itself. But this is a trick you may not have pulled before, or maybe not for a while. So watch the details on this. Check this out. If I had something like an x to the 9/4 power, and I wanted to get the x by itself, what we can do is we'll take the whole thing to another power that will cancel out the power we got. And so what we'll times by is the reciprocal. We'll take it all. We're not timesing. We're taking this thing to the power of 4/9. And I'm going to do that to the other side as well. Here, actually, let me move this 3 to the 10, so we'll have room here, 3 to the 10. And then we'll have to take this side to the 4/9 power as well. The reason that helps is because now the 9s will cancel and the 4s will cancel, because remember, with exponents, a stacked exponent, really you do end up timesing them. So now we just got x to the 1, or just x, equals whatever the heck all this is on the left, and that'll be a 3 to the, and then we got to times the powers here. So timesing those powers, that'll be 10/1 times 4/9. That's 40/9, it looks like. How about that? It's 40/9. I don't think it reduces, so that's cool. And then that's calculator work, because it's not like it's 3 times 40/9. That's the 40/9 is an exponent. Here, I'll write it big so it looks more clear. 3 to the power of 40/9. And that's really not worth trying to figure out by hand. It'd take you all day. Anyway, that's calculator work. You can either enter it in just like that into the into the answer box here, and just put 3 to the 4/9 power right in there, or 49ths, or else you can round it off to 4 decimal places with a calculator. That's all she wrote.